Now, Keysight, as well as making test equipment of the type you're probably familiar with, where we have cables and all the rest of it, we have a major part of our company which does simulation tools. And one of those is called SystemVue. And the next few slides show you some of the things that we can do with that tool in order to help you in designing antennas and analyzing the performance. These figures are examples of different types of array, and this one here is the one that's the default assumption for the current work on UE requirements. And you can see also here what that antenna might look like with a larger number of elements. You obviously get higher directivity and lower side lobes, and it all looks much more peaky. But that's the one we're working with at the moment. Other implementations are not precluded. This is just an assumption we need to make to develop requirements. As well as the number of elements in the array, also the array spacing is important, and the one that's been assumed is the half lambda spacing. So now we know how big the base station antenna is for any one frequency. And we can see the impact that the array spacing has on the theoretical performance of the antenna. But that's the one we're using there, the second one along. Now, that's at bore site. What happens when you start to steer this antenna? So this here shows you the analysis of what the beam width looks like when you start to steer it. And you can see that it all looks quite nice on the bore site where your elements are basically pointing. But as you start to steer off, you now start to see the beam width getting worse. So you started off with 12 degrees and then it starts to get worse and worse. And then at the end here, you can't really tell the difference between 75 and 90. There's really not a lot happening there. So this is an important aspect of the design, and you can optimize the design to improve the quality of this performance. But this is the basic assumption that we're working with in the standards.